So here's a second, very slightly different example. The thing that makes this example different is we're working with a sine here. Now that's not going to change our process further down, but it is going to change our starting point. I'm just highlighting these to remind us we're working in degrees when we find our alpha, and we're working with a k that's bigger than 0. Now that difference, that k sine, so let's work out what to do with that. If you look up your formula sheet, and I will actually post one on the team in the files section as well, just in case you've not got one, so you can see where this is. But we get sine of a plus b, or sine of x plus alpha, is the same as sine of x cos alpha plus, the pluses match on this version, cos of x sine of alpha. So I'm just using that identity, but I'm putting in my x and my alpha instead of my capital A and capital B. Expanding that out, and again I'm going to bring my cos alpha to the front here just to make my comparison easier in a second. And again bring the sine alpha to the first term just to make my comparing easier. So we've got that. Now that's the only difference here in this example, because we're using the sine there rather than the cos. We need to use the sine identity rather than the cos one. But we can now do our comparing. So we have our cos x here and our cos x here. That means my k sine alpha must match the thing that comes in front of cos x, which is k, which is 8. So we have k sine alpha equal to 8. Now we've got exactly the same thing with our second bit, comparing what comes in front of our sine. Well, we have k cos alpha, and up here we have 6. So that gives us k cos alpha equal to 6. Now we're off, because this is just the same process we went through last time. So we have our k sine of alpha all squared plus our k cos of alpha all squared. Well, what is that? Well, sine alpha is 8, so that becomes 8 squared plus what's cos alpha was 6. So that is 6 squared. This side here, you can run through all the details if you really want to, or you can take that shortcut of knowing what the starter says. It says that all of that becomes k squared. If you want to run through all the details, you can, but you are very welcome to shortcut that. 8 squared add 6 squared, that's 64 add 36, which is 100. And so k here is plus or minus 10, but we're only interested in the plus 10 because k is greater than 0. Second part, we're trying to find alpha, so we do k sine of alpha over k cos of alpha. Well, what does that look like? Well, k sine alpha is 8, k cos alpha is 6, and so we can simplify that to tan alpha, because our k's cancel out and sine over cos is tan, and we get 8 over 6. Once we're there, we're on to a good thing, because we can now find what alpha is. Now we need to, I shouldn't really have written alpha there, I should have written the relative acute angle, but you'll see why I didn't in a second. On my CAST diagram, tan is positive, so we're either down here or up here, but sine is positive and cos is positive, so that is that and that. And so in this case, our relative acute angle is the same as alpha that we're going to find by doing tan to the minus 1. So this is my relative acute angle, but it's also my alpha in this example. So doing tan to the minus 1 of that gives me 53.130102, or round that, we get 53.13 degrees. We're finished. All we need to do is put that into our final form. So our conclusion is that 8 cos of x plus 6 sine of x is equal to k times sine of x plus our alpha was 53.13. And we're finished. So that is our final answer. And hopefully that makes, shows you it's not a tedious, long process as I maybe made the first video make it seem. We can turn these out. They become a bit routine. It's the same steps every time. I am going to do one more of these as an example. You'll spot I haven't put any your turns in this time, but I will put the work solutions up. So as you do the questions that I'm going to set, you can just check against the worked examples and use that as your turn. Check each one as you do it and then fix any little mistakes. And of course, feel free to ask questions as you work through these. That is absolutely fine. So one more video showing you something very slightly different that can happen. But you'll see the mechanics of what we're doing is exactly the same.